Welcome to the Explainer. So, today we're going to completely change how you think about talking to AI. Seriously, if you've ever typed out a prompt, hit enter, and just felt totally let down by the generic response you got back, you're exactly in the right place. We're unpacking some brilliant work today from Dr. Ed Pearson III over at the Core Lab. And yes, I want to emphasize that CORE lab, not CRE lab. What he's done is shift prompt engineering away from this frustrating guessing game into a rigorous, predictable science. We're going to dive right into exactly how to refine your prompts systematically so you actually get professional, verifiable outputs every single time. Okay, let's dive into this. Here is our clear roadmap for today. First, the first prompt myth. Second, prompting as a science. Third, the 6-step pace loop. Fourth, the 5-question diagnostic. And finally, equity in AI refinement. Before we get into the mechanics of it all, I really want to anchor us to this phenomenal quote from Dr. Pearson. He says, "The goal is not to use AI better. It is to think better with AI as your instrument." I mean, how great is that? We aren't just learning how to press buttons faster today. We're learning how to use these models as analytical tools to actually elevate our own thinking process. Think of this as our laboratory session, and, well, that's our guiding philosophy. All right, section 1, the first prompt myth. Most of us have this really ingrained habit. We write a prompt, we hit enter, and we expect absolute magic right out of the gate. But we absolutely have to break that myth through what's called iterative refinement. See, because large language models generate probabilistic outputs, your very first prompt is never a finished instruction. It's actually, it's merely a hypothesis. You're simply testing how the model interprets your initial parameters. So you improve the quality through deliberate, structured cycles, rather than just getting frustrated, deleting the whole thing, and rewriting a prompt from scratch. So why do these first attempts almost always fail to hit the mark? Well, it usually boils down to vague problem statements or missing context. It is the classic garbage in, garbage out scenario. Think of it kind of like walking into a restaurant, saying, "Hey, I'm hungry," and then getting mad when the chef hands you a bowl of soup instead of a steak. If your prompt doesn't name specific locations, data points, or community context, the model literally has to guess. Sure, it might perfectly execute the mechanical task of writing a list or a summary, but without your specific context, it's answering the wrong question entirely. Moving right along, section 2, prompting as a science. If the first prompt is just a hypothesis, it means we need a scientific method to test it. And this brilliantly illustrates the difference between a professional and an amateur. On one side, you have a controlled experiment where you change exactly one variable at a time. On the other side, complete chaos. That's when you rewrite the whole prompt and change everything all at once. Look, if you change every single part of your prompt and it miraculously works, you learn absolutely nothing for the next time. But if you change just one pace component, that gives you transferable knowledge that you can use on literally every future prompt. Now for section 3, the 6-step pace loop. Okay, here is the pace refinement loop, the exact experimental procedure we need to follow in the lab. Step 1, write your initial prompt, making sure you have all 4 components. That's problem, action, context, and expectations. Step 2, submit it. Step 3, evaluate that output against specific criteria. Step 4, identify the single weakest component. Step 5, revise only that one component. And finally, step 6, resubmit and compare. It's a really tight logical routine. And listen, don't expect instant magic here. Professional-grade outputs typically require 3 to 5 full cycles. Which brings us to section 4, the 5-question diagnostic. So how do we actually measure our experimental data objectively? Well, during step 3 of the loop, you have to ask these 5 critical questions. Number 1, accuracy, like can you actually verify the facts? Number 2, completeness, did it answer the full question? Number 3, contextual fit, does it genuinely reflect your specific community? Number 4, verifiability, did it cite its sources? And number 5, bias and limits, did it rely on stereotypes? And here's the kicker. Before you make any revisions based on pure instinct, you absolutely must rigorously rate every single dimension as yes, partial, or no. Now, what's really interesting here is how this framework takes the guesswork completely out of revising. Once you've rated your output, your failing dimension maps directly to the specific pace component you need to fix. So, if accuracy or verifiability fails, revise your expectations to demand citations. If contextual fit fails, you revise your context to add an equity lens. Failing on completeness, upgrade the action component with a stronger, more specific verb. The diagnostic literally tells you exactly what to do. So the crucial point is this. We really have to reframe how we view bad AI responses. Weak outputs are not failures, they are scientific evidence. Getting a partial or no rating on any of those 5 questions isn't a dead end at all. It's honestly a compass. It points straight to your weakest prompt component, telling you exactly what you need to test in your very next refinement cycle. Let's look at a really powerful real-world example of this. Draft 1 just asks why Black women die from pregnancy-related causes at higher rates. And, as you'd expect, it yields a generic, placeless list of national issues. But look at Draft 2. By systematically targeting just the context component, the prompt now specifies Jefferson County, Alabama. It includes the exact mortality rate of 47.2, and it notes structural factors like NICU availability. It's amazing. Just one focus cycle transformed a vague question into a highly specific, verifiable, community-grounded analysis.
But even with the loop, traps definitely remain. Mistake 1 is rewriting the whole prompt. Mistake 2, though, is incredibly dangerous, accepting a fluent output as correct. You have to remember an LLM's default state is to sound highly articulate and confident, but fluency does not guarantee accuracy. Mistake 3 is skipping that systematic evaluation step just based on a gut feeling. And mistake 4, stopping after just one cycle. One cycle improves things, for sure, but multiple cycles are what make it trustworthy.
All right, last one. Section 5, Equity in AI Refinement. Let's move to and see how this builds into the human element, because this introduces the massive risk of context drift. See, as you refine prompts to make the output flow better, there's a real danger of erasing demographic and geographic specificity. Refinement without a strict equity lens naturally tends to narrow toward the majority. It creates this placeless output that sounds super confident but talks about nobody in particular. Plus, demanding high specificity can sometimes cause the AI to hallucinate statistics. That is exactly why constant checks on accuracy and verifiability are completely non-negotiable. We've moved from guessing to science, from total chaos to structured loops. But the ultimate test of a refined output isn't just whether it sounds professional, it's whether it accurately reflects lived realities. So as you apply your new scientific prompting skills, I want to leave you with this thought to carry into your next project. When you refine your prompts, who are you inadvertently erasing? I really want you to think about that next time you sit down to iterate. Thanks so much for joining me on this explainer, and I will see you next time.